Hello friends, welcome to my e-clinic. This is Dr.Shifa Deshmukh. If you haven't subscribed yet, please make sure you do it now. So, today you will learn about the morphological stages of tooth development. Friends, if you haven't watched my video of development of tooth part 1, then please make sure you watch that first, in which I have explained about dental lamina. It will be better if you watch that video first so that it will be easy for you to understand my upcoming lectures. I am sharing the link in description box. Before beginning, I'm asking you a question from my previous lecture. Following is the derivative of dental lamina: epithelial rests of Malleus, enamel pearls, rests of Ceres, or all of the above. So now let's study first about dental terminology. What is dental organ, dental papilla, and dental sac or follicle? In the earlier lecture, we have seen that on the dental lamina, at the site of tooth formation, ectodermal cells proliferate more rapidly to form knob-like structures, and these structures are called nothing but the enamel organ. Okay, what is dental papilla? As the proliferation of the cells continues, the enamel organ, it increases in size and changes its shape. Now, as it grows and changes in shape, it takes the shape of a cap. In the depression of the cap, the ectodermal cells begin to condense, and this condensed ectomesenchymal cells are called as the dental papilla. What is dental follicle or sac? Surrounding the enamel organ and the dental papilla, there is marginal condensation of the ectomesenchyme, and this is called as the dental sac. Now, the tooth germ, as we have seen, is made up of three parts: the enamel organ, the dental papilla, and the dental sac. Out of these three components, only the enamel organ is the ectodermal component because it arises from oral ectoderm, while the dental papilla and the dental sac are the ectomesenchymal component because they arise from ectomesenchyme. This enamel organ results in the formation of enamel of the tooth, while the dental papilla results in the formation of dentine and pulp, and the dental sac forms the cementum, alveolar bone, and the periodontal ligament of the tooth. So after understanding these basics, let's now study the morphological stages of tooth development, which are the bud stage, cap stage, and the bell stage. And they are named so after the shape of enamel organ in the respective stages. In the bud stage, the enamel organ appears as a flower bud. In the cap stage, it appears as a cap, and in the bell stage, it appears as a bell. Now let's study in detail about the bud stage. We have seen in the earlier lecture that at 10 different points of dental lamina, round swelling arises from the basement membrane, corresponding to the future position of primary teeth. These round swellings are the enamel organ, and the bud stage is the initial stage of tooth development in which the enamel organ appears as a bud. So it is called as the bud stage. When we see this bud stage in light microscopy, we can see that it is lined peripherally by low columnar cells, and in the center position there are polygonal cells. Also, there is initiation of condensation of the ectomesenchyme below the bud, which is called as the dental papilla, and also there is marginal condensation of the ectomesenchyme forming the dental sac. Now, what is the cap stage? The tooth bud undergoes unequal growth in different parts, which results in the formation of cap-shaped structure with a shallow invagination on the undersurface. When we see this cap stage under the light microscopy, we can see three types of cells. The cells which line the convexity of the cap are the outer enamel epithelium, and they are cuboidal in shape. And the cells which line the concavity of the cap are called as the inner enamel epithelium, and they are tall columnar. And in the center, there is stellate reticulum cells. These are polygonal cells present between the outer enamel epithelium and inner enamel epithelium. But what happens is that in the cap stage, water is pushed in due to osmotic pressure, due to which these polygonal cells they shrink and become star-shaped. Now these star-shaped cells are in contact with each other by long processes. So this stellate reticulum-like cells form a network or star-shaped cells. Thus, it gets its name as stellate reticulum. Stellate means star and reticulum means network. This stellate reticulum has a very important function in tooth development. It has a cushion-like effect, or it acts as a shock absorber, and it protects these delicate enamel forming cells of the inner enamel epithelium. Also, in the invagination of the gap, there is condensation of the ectomesenchymal cells to form the dental papilla, and this dental papilla in the cap cells show numerous budding capillaries which provide nutrient supply to the inner enamel epithelium and the forming odontoblast in the future. Also, there is marginal condensation of ectomesenchymal cells to form the dental sac, which is a denser and fibrous layer. In the cap stage, there are few transient structures which are present. These are enamel knot, enamel cord, enamel septum, and enamel navel. Now, what is enamel knot? In the center of the enamel organ, there is a group of densely packed cells called as the enamel knot. The vertical extensions of these enamel knot cells is called as enamel cord. When this enamel cord extends up to the outer enamel epithelium, it is called as the enamel septum. This is called as enamel septum because it divides the stellate reticulum into two parts. So, when this enamel septum reaches up to the outer enamel epithelium, it forms a shallow depression in the outer enamel epithelium to form the enamel navel. Also, there is a structure called as enamel niche. This enamel niche is ectomesenchyme enclosed between two attachments of the enamel organ. In the cap stage, the enamel organ appears to have a double attachment with the ectoderm. In between these two attachments, there is a small portion of the ectomesenchyme which is entrapped, and this is called as enamel niche. Now, let's come to the bell stage. In the bell stage, the crown shape is determined. When we see the bell stage under light microscopy, we can appreciate four types of cells. The inner enamel epithelial cells, which line the concavity of the bell. These are tall columnar cells which in future differentiate into ameloblasts. Then there are few layers of squamous cells called as stratum intermedium. This stratum intermedium is very essential for enamel formation, so it is present only in the crown portion of the tooth bud and it is absent in the portion of the tooth germ which forms the root. And these cells show high metabolic activity. Then there is stellate reticulum cells which further collapse, reducing the distance between the ameloblasts and the capillaries near the outer enamel epithelium. And the outer enamel epithelial cells, which are the low cuboidal cells, and towards the end of Bell stage, it shows small folds which encloses the ectomesenchyme, and through the capillaries of ectomesenchyme, it provides nutrition to the ameloblast-like cells. Now the dental papilla, which is present in the Bell stage, shows the peripheral cells differentiating into odontoblasts. And these odontoblast cells will form the dentine in the future. So what about the dental sac in the Bell stage? Before the dental tissues are formed, the dental sac shows circular arrangement with the development of the root. The fibers of dental sac differentiate into periodontal ligament fibers. Now, what is membrana preformativa? The basement membrane that separates the enamel organ and the dental papilla just prior to the dentine formation is called as the membrana preformativa. Also, we can appreciate in the Bell stage that when the deciduous tooth buds are in the Bell stage, we can appreciate the successional lamina showing the permanent tooth buds in the bud stage. That is, the enamel organ of deciduous teeth in the Bell stage shows successional lamina with the permanent tooth buds in the bud stage. Time for some questions. Ectodermal cells in tooth bud are responsible for determination of shape of crown and root, formation of PDL, formation of cementum, or formation of pulp. Which of the following is not an ectomesenchymal derivative? Dentine, cementum, pulp, or enamel? In cap stage, regulating factor for cusp shape formation is present in dental papilla, follicle, inner enamel epithelium, or enamel knot. So in this lecture, we have covered the bud stage, cap stage, and the Bell stage. In the next lecture, we will be learning about the advanced Bell stage and the Hertwig's epithelial root sheet. Thanks for watching. Don't forget to like, share, and subscribe to my channel.